Hello, my name is Tsang, and today I will be going over a Chapter 2 question in the Nelson Advanced Functions textbook. This question is in the Chapter 2 Self-Test section of the textbook, page 118, question 2, just in case you would like to reference this question later on. Question 2 states, a cup of hot cocoa left on a desk in a classroom had its temperature measured once every minute. The graph shows a relationship between the temperature of the cocoa in degrees Celsius and time in minutes. Question A asks, determine the slope of the secant line that passes through the points 570 and 5025. Question B asks, what does the answer to part A mean in this context? Question C asks, estimate the slope of the tangent line at the point 3035. Question D asks, what does the answer to part B mean in this context? Question E asks, discuss what happens to the rate at which the cup of cocoa cools over the 90-minute period. So I know that I have to use my knowledge of A-rock, I-rock, secant lines, tangent lines, slope, and applying answers to the context of the question in order to answer this overall question. Let's take a look at the graph provided. On the x-axis, we have time, which is measured in minutes, and goes up by increments of 10. On the y-axis, we have temperature, measured in degrees Celsius, and goes up by increments of 5. As we can see here, there's a negative slope, so as time increases, the temperature decreases. So starting off with question A, it asks, determine the slope of the secant line that passes through the points 570 and 5025. Okay, so what we're going to do to answer this question is we're going to insert the points into the slope formula. Here on the graph, I just plotted the 2 points and drew the secant line, so we can now just visualize it a little bit better what we're measuring the slope of. Let's first start off by writing down the points again. So 5 and 70 and 50 and 25. We can now label these x1, x2, y1, y2. Now we're going to sub these points into the slope formula, which is m equals to y2 minus y1 over x2 over x1. We can now sub in these points. So 25 minus 70 over 50 minus 5. 25 minus 70 is negative 45, and 50 minus 5 is 45. So m equals to negative 1. Question B now asks, what does the answer to part A mean in this context? So in here at question B, we're taking our answer that we got in question A, and we're applying it into the context of the question. So we can start by saying the hot cocoa is cooling down. And we know that's cooling down because there's a negative in front of the number that we got at an average rate, because we found the slope of the secant line of 1 degrees Celsius per minute. And we also just applied our units into our answer. Question C asks, estimate the slope of the tangent line at the point 30, 35. So what we're going to do first is we're going to find a point near or on the tangent line. So now that we have 2 points, we can now insert them into the slope formula. So I drew the tangent line at x equals to 30 and y equals to 35, and I can see that the point 10 at x and 50 at y is also very close to that tangent line. So we can use that point and now use our slope equation to estimate the slope of this tangent line. So I'm just going to jot down the points again. So 10 and 50 and 30 and 35. We can now label these. So let's do 35y2, 50y1, 30x2, and 10x1. So we can now sub these points into our slope formula, which is m equals to y2 minus y1 over x2 over x1. So it will come out to 35 minus 50 over 30 over 10, which is going to equal to negative 15 over 20. So m is going to be approximately, which is why the dot is there, negative 0.75. Question D asks, What does the answer to part B mean in this context? I think that they're talking about part C, so let's just answer this question in terms of the answer from part C. Okay, so here in question D, we're taking our answer from question C and just applying it to the context of the question. So we can start off by saying 30 minutes. And remember, we're saying 30 minutes because in the point 30, 35, the x value is 30 and the x axis is labeled time in minutes. So at 30 minutes of the hot cocoa being left out on the desk, it would be cooling down at approximately 0.75 degrees Celsius per minute. Okay, so remember here we're saying approximately because we took another point along not along the tangent line, but to the side of the tangent line to find the slope of it. So we're going to say approximately because not the point that we chose was not directly on the tangent line. And also we're saying cooling down by 0.75 degrees because there's a negative before the 0.75. And then we're going to apply Celsius per minute as we're just going to add the units in. Question E asks, discuss what happens to the rate at which the cup of cocoa cools over the 90-minute period. To better visualize this, I drew a tangent line at time equals to 90. And as we can see, the line is pretty much horizontal, meaning the rate of change is very minimal and the temperature has reached close to room temperature. The temperature will continue to decline as time goes on until it reaches room temperature and the temperature of the once hot cocoa becomes constant. A job which often uses the skills which we use to answer these questions, such as average rate of change and often being familiar with secant and tangent lines, are meteorologists. Meteorologists often deal with comparisons between weather and dates to find abnormal changes which may have occurred. This is significant in finding global warming statistics, which is currently a global worldwide issue. Thank you for watching and listening. I hope that I taught you something new today. Have a fantastic rest of your week.